Welcome to the Unit 8 Section 2 video on operations with polynomials. Just as you can perform operations on numbers, you can perform operations on polynomials. To add or subtract polynomials, you are going to group the like terms together and then find the sum, or write them in column form. Okay, so we're going to go over both methods here as we do a couple of examples. So let's start with example 1, where we're going to add two polynomials. So the first method is grouping like terms. We're going to take our two polynomials and we are going to group together the y squared terms. We're going to group together our y terms. In this case, there's only one. And then we're going to group together our constant terms, or our numbers. Now that we have them grouped together, we're just going to combine them. 3y squared plus 7y squared gives us 3 plus 7y squared. We've got the 5y, and then we've got negative 6 plus negative 9, which gives us negative 15. 3 plus 7 gives us 10y squared. Then we have our 5y, and then finally minus 15 on the end. We can also add in column form. So to do this, you're going to take the first polynomial and stack it on top of the second polynomial, putting like terms together. And when you do that, we have 3y squared plus 7y squared, which gives us 10y squared. Our plus 5y comes down, and then negative 6 plus negative 9 gives us negative 15. So we end up with 10y squared plus 5y minus 15. Here's another example where we have two trinomials and we're subtracting. So let's group like terms by putting together our x squared terms. We're going to put together our xy terms, and we're going to put together our y squared terms. Now notice, in each case, we are subtracting that second set because we have a minus sign in front of that second trinomial. We are subtracting the 6x squared, we are subtracting the 8xy, and we are also subtracting the 3y squared. Now let's combine our like terms. So we have 4x squared minus 6x squared, which gives us negative 2x squared. 5xy minus 8xy gives us negative 3xy. And then negative 3y squared minus 3y squared gives us negative 6y squared. And now all that's left to do is to clean it up a little bit and pull our minus sign. So we've got negative 2x squared minus 3xy minus 6y squared. The second method, we can subtract in column form. Again, stack the first trinomial with the second trinomial and subtract them going down. 4x squared minus 6x squared gives us negative 2x squared. 5xy minus 8xy gives us negative 3xy. And negative 3y squared minus 3y squared gives us negative 6y squared. To multiply monomials and polynomials, you will use some of the properties of exponents. You will also use the distributive property. So let's do an example of this. 5a times the quantity 3a squared plus 4. First, we're going to distribute the 5a to the 3a squared. We'll distribute the 5a to the 4. And then we'll multiply each piece. So 5a times 3a squared gives us 15a cubed. 5a times 4 gives us 20a. So our final answer is 15a cubed plus 20a. Let's multiply 2m squared times the quantity 5m squared minus 7m plus 8. So we'll start off by distributing the 2m squared to each of the three terms. Then we're going to multiply each set. So when we multiply 2m squared times 5m squared, we get 10m to the fourth. Negative 2m squared times 7m gives us negative 14m to the third. And then 2m squared times 8 gives us 16m squared. Let's multiply negative 3xy times the quantity 2x squared y plus 3x squared, or 3xy squared minus 7y to the third. So we'll distribute the negative 3xy to each of the three terms, and then we will multiply them out, giving us our final answer of negative 6x cubed y squared minus 9x squared y cubed plus 21xy to the fourth. To multiply a binomial by a binomial, you can apply the distributive property more than once. So let's take the quantity 2x plus 3 times the quantity 5x plus 8. We can distribute the 2x to the second piece, 5x plus 8, and then we'll distribute the 3 to the second piece, 5x plus 8 again. When we do this, we're going to multiply out the 2x and the 5x, and the 2x and the 8. In the second part, we will multiply the 3 and the 5x, and the 3 and the 8. This gives us four terms, 10x squared plus 16x plus 15x plus 24. And then finally, we combine our like terms, 16x and 15x, which gives us 31x as our middle term. So let's multiply out the quantity y plus 5 times the quantity y plus 7 using the distributive property. So we first distribute the y in the first term to everything in the second term. Then we'll distribute the 5 in the first term to the y plus 7 as well. So when we multiply these things out, we get y times y and y times 7. In the second piece, we have 5 times y and 5 times 7. So this gives us y squared plus 7y plus 5y plus 35. And then finally, combine your two middle terms to get y squared plus 12y plus 35. Another method for multiplying binomials is called the FOIL method. And really, the FOIL method is nothing different than what we just did. It just helps you remember the order in which to do things as you're distributing. Now, it's important to note that this method only works for binomials. So to multiply two binomials, you'll find the sum of the products of the first terms, the outer terms, the inner terms, and the last terms. F for first, O for outer, I for inner, L for last. So here's a look at how it works. We're going to start by multiplying our first terms. So 2x and 5x will get multiplied together. Then we're going to move to our outer terms. So our 2x and our 8. Then we're going to multiply together our inner terms, the 3 and the 5x. And then finally, we're going to multiply our last terms, the 3 and the 8. Then we multiply each piece out. We get 10x squared plus 16x plus 15x plus 24. And we combine our middle terms to get 10x squared plus 31x plus 24. So let's multiply these two binomials using the FOIL method. We start with our first terms, 3x times 5x. Then we go to our outer terms, 3x times 2. Then we go to our inner terms, negative 5 times 5x. And finally, our last terms, negative 5 times 2. Then we go ahead and multiply each set out, getting 15x squared plus 6x minus 25x minus 10, and then combine our two middle terms. 6x minus 25x gives us negative 19x, and then the minus 10 on the end. To multiply polynomials with more than two terms, you can use the distributive property several times. So let's take this binomial and multiply it by the trinomial. So to do this, we're going to take the first term in our binomial and multiply it across our trinomial. Then we'll take the second term in our binomial and multiply it across our trinomial. Then we will distribute each piece. So we'll do 5x times 2x squared, 5x times 10x, and 5x times negative 6. Then we move on to the other piece that we need to distribute. 3 times 2x squared, 3 times 10x, and 3 times negative 6. Now we go ahead and multiply each piece, getting 10x cubed plus 50x squared minus 30x plus 6x squared plus 30x minus 18. So all I did was multiply each pair in the line above. Now the last thing to do is combine your like terms. There's nothing to combine with the 10x cubed, so that sits alone. 50x squared plus 6x squared gives you 56x squared. Negative 30x plus 30x gives you 0x, so we don't need to write that down. And then we have negative 18 on the end. So let's do an example. We're going to multiply this binomial by a trinomial using the distributive property. So again, we are going to take the binomial, we'll split it across our trinomial and distribute each piece. 2x times the trinomial and negative 5 times the trinomial. When we do this, we'll get 2x times 3x squared, which is 6x cubed. 2x times negative 5x gives you negative 10x squared. 2x times 4 gives you 8x. Then we will do minus the 5 distributed. So we get 15x squared minus 25x plus 20. Then let's distribute the negative sign across that second trinomial, and then combine our like terms to end up with 6x cubed minus 25x squared plus 33x minus 20. You can also use a rectangle model to multiply polynomials with more than 2 terms. This is similar to finding the area of a rectangle with length of the trinomial and width of a binomial. To find the product, add all the terms inside the rectangle by combining like terms and simplifying if necessary. So I have a rectangle divided up as 3 across for the trinomial and 2 down for the binomial. Now you're going to multiply whatever is above your rectangle and whatever is to the side of your rectangle in each of these 6 rectangles. So 2x squared times 5x gives you 10x cubed. 10x times 5x gives you 50x squared. Negative 6 times 5x gives you negative 30x. 2x squared times 3 is 6x squared. 10x times 3 is 30x. And negative 6 times 3 is negative 18. Now take everything that's in the rectangles, write them across, and then combine your like terms to get your final answer. So let's do another example using the rectangle model, multiplying a binomial by a trinomial. So our trinomial is going to go across the top, binomial across the side, and you could do it the other way. You could put your binomial across the top and then have a 2 wide and 3 tall rectangle. Either way works. We're going to multiply out each pair and get our answers in each of these 6 boxes, and then line up our box answers, and then combine our like terms to get our final answer. 2x cubed minus 9x squared minus 8x plus 15. And I encourage you to pause the video and take the time to write this down and look at what was done in this example. It was performed just like the one above it. Another method that can be used to multiply polynomials with more than 2 terms is the vertical method. This is similar to methods used to multiply whole numbers. So we have 2x squared plus 10x minus 6 times the binomial 5x plus 3. So we're going to start with the negative 6 times 3, which is negative 18. Then we'll do 3 times 10x, which is 30x. Then 3 times 2x squared, which gives us 6x squared. Now we move to the 5x. 5x times negative 6 is negative 30x. We stack that underneath the x term. 5x times 10x is 50x squared. And then 5x times 2x gives us 2x squared gives us 10x cubed. And then we add together the 2 lines to get 10x negative 18 on the end 0x, 56x squared, and 10x to the third. And then we don't have to write the 0x, so we just simply leave it as a trinomial, 10x cubed plus 56x squared minus 18. So let's do an example with another binomial times a trinomial. We write out our trinomial here, but you notice there's no x squared term. So we're going to insert a 0x squared because you want to have every power of x when you do this. Then we're going to put our 3x minus 4 below it, and we're going to multiply, starting with negative 4 times negative 6, which is positive 24, negative 4 times 5x, which gives you negative 20x, negative 4 times 0x squared still gives us 0x squared, negative 4 times negative 2x to the third gives us 8x cubed. Now we move on to our 3x. 3x times negative 6 is negative 18x. 3x times 5x gives us 15x squared. 3x times 0x squared gives us 0x cubed. And then 3x times negative 2x cubed gives us negative 6x to the fourth. Now we add together everything and get 24, negative 38x, plus 15x squared, positive 8x to the third, and negative 6x to the fourth. And that is our final answer. Let's multiply two trinomials, and we'll use the distributive method for this one. You can use any method you would like. All the methods that I showed you, all three, distributive, using the rectangle box method, as well as the vertical method, all three of these would work for multiplying trinomials, but we'll use the distributive method here. So we will distribute out the x squared across the second trinomial. We'll distribute the negative 5x across the trinomial, and we'll distribute the 4 across the trinomial. Now we're going to distribute each of these pieces. With the x squared, we are going to distribute to the first term, to the second term, and to the third term. We'll distribute the negative 5x to the first term, the second term, and the third term. And then we'll distribute the 4 to the first term, the second term, and the third term. And now all that's left is to combine your like terms. We only have one x to the fourth term, so that will come down. We have two x cubed terms. We have x cubed minus 10x cubed, which gives us negative 9x cubed. We have three x squared terms, negative 7x squared, negative 5x squared, and 8x squared. When you combine those, you get negative 4x squared. Then we move on to our x terms. 35x and 4x make 39x. And then finally, negative 28 on the end. Let's go back to binomials and talk about some special products, because if we can recognize some special products, we can find the product of binomials much faster. So let's take a square with sides of length a plus b. You see that on the top and over on the left-hand side. We have a portion of the length as a and another portion of the length which is b, and when added together you get the total length of the side, which is a plus b. The area of the square is a plus b times a plus b, or you can also write it as a plus b quantity squared. The area of the square can also be found by adding the areas of the smaller squares and rectangles inside. So if we take the four portions that we have divided the square into, you have a portion that is a times a, which gives us a squared. Then we also have a rectangle that is a times b, which is ab. Then we have another rectangle, which is b times a, which is also ab. And then we have the final right-hand corner, that is b squared, b times b. So the sum of the areas inside would be a squared plus ab plus ab plus b squared. And of course we have two like terms in the middle that we can combine. 1ab plus 1ab gives us 2ab. So this means that a plus b quantity squared is going to equal a squared plus 2ab plus b squared. You can use the FOIL method to verify this. If we take a plus b quantity squared, we can FOIL it using a plus b times a plus b. That would give us a times a for the first terms. The outer terms gives us a plus b. The inner terms give us b plus a, or b times a. And then the last terms gives us b times b. Now we have a squared plus ab plus b squared, which is a squared plus 2ab plus b squared. This is the square of a sum. We can say that a plus b quantity squared is a squared plus 2ab plus b squared. And we'll do an example showing how you can use this. Why is this useful? How does this make this faster? We'll do an example of that a little bit later. But for now, another thing that you need to know is that the trinomial of the form a squared plus 2ab plus b squared is called a perfect square trinomial. A perfect square trinomial is a trinomial that is the result of squaring a binomial. And a little bit later, in a later unit, it's going to be important to know how to recognize a perfect square trinomial. You can use the FOIL method to find the products in the form a minus b quantity squared as well. So we take a minus b quantity squared. We can multiply it as a minus b times a minus b. Do the first, outer, inner, and last terms. And we get a squared minus ab plus b squared, which is a squared minus 2ab plus b squared. And this is a square of a difference. So you've got a minus b quantity squared is equal to a squared minus 2ab plus b squared. The trinomial of this form is also a perfect square trinomial because it is the result of squaring the binomial a minus b. So let's do some examples. We're going to multiply each square polynomial. So we'll start with 3x plus 2y quantity squared. We're going to take our square of a sum, and we're going to take a as being 3x, b as being 2y. So we start with our 3x quantity squared. We're going to take our 2 times a, which is 3x, times b, which is 2y, and then we'll take our b, 2y quantity squared. And now all we have to do is clean it up a little bit. 3x quantity squared is going to be 9x squared. Remember, you have to square the coefficient as well as the variable because we're squaring the entire thing. 2 times 3x times 2y gives us 12xy. And then 2y quantity squared, we have to square everything, so that's going to give us 4y squared. Let's do another one. Now let's do a square of a difference. We have 6a minus 1. So using the square of a difference, we have a is 6a, b is 1. So we have 6a quantity squared minus 2 times 6a times 1, since b is 1, and then 1 squared. We square the first, 36a squared, multiply the middle terms to get minus 12a, and then squaring 1 gives us plus 1 on the end. You can use an area model to see that a plus b times a minus b is equal to a squared minus b squared. So let's begin with a square with the area of a squared. Each of the sides is a, so a times a gives us an area of a squared. We're going to remove a square with the area b squared. The area of the new figure is going to be a squared minus b squared. Now if we take the part that is left, we remove that b square area, and we divide it into two rectangles, you'll notice that we have on the left-hand side a portion that is length b and a portion that is length a minus b. On the top and bottom end, we have a length of a and a length of a minus b. If we take the a minus b that is on the bottom and turn it on its side to match up with the a minus b on the top left, we end up with a larger rectangle which has the area of a plus b times a minus b. And since this is the same area as we had in the first step, we can now say that a plus b times a minus b, that should be a minus b in the second piece there, is equal to a squared minus b squared. A binomial of the form a squared minus b squared is called a difference of two squares. And so this is the correct form here. We've got a plus b times a minus b is equal to a minus b times a plus b, because it doesn't matter which way you multiply things. Either way, it is equal to a squared minus b squared. So let's use this to multiply each sum and difference here. Here we have x plus 6 times x minus 6. We use our form to plug in x for a and 6 for b. And that's simply going to give us x squared minus 6 squared, and of course 6 squared is 36. So you have x squared minus 36. For x squared plus 2y times x squared minus 2y, we have a being x squared, b is 2y, so we square x squared, we subtract 2y squared, and that's going to give us x to the fourth minus 4y squared as our answer. A set of numbers is closed or has closure under a given operation if the result of the operation on any two numbers in the set is also in the set. So recall, the set of integers is closed under addition because adding two integers results in another integer, and that's always going to be the case. Polynomials can also be described in terms of closure. So first, we have closure under addition. When adding polynomials, the variables and their exponents do not change. Only their coefficients will possibly change. This guarantees the sum has variables and exponents which are already classified as belonging to polynomials. So in this example, we're going to show that these two polynomials are closed under addition. So when we add the two polynomials, you end up adding like terms. So we get 3x squared minus 2x plus 1. Since the result is also a polynomial, then the given polynomials are closed under addition. Closure under subtraction. When subtracting polynomials, the variables and their exponents do not change. Only their coefficients will possibly change. This guarantees that the difference has variables and exponents, which are already classified as belonging to polynomials. So very similar to addition. If we take two polynomials and we subtract them, we end up with x squared plus 8x plus 7, which is also a polynomial. So therefore, polynomials are closed under subtraction. For multiplication, when multiplying polynomials, the variables' exponents are added according to the rules of exponents. Remember that the exponents in polynomials are whole numbers. The whole numbers are closed under addition, which guarantees the new exponents will be whole numbers as well. So, if we take these two polynomials and we multiply them, so here we're multiplying, not adding, we will actually get another polynomial. So since the result is a polynomial, then the given polynomials are closed under multiplication. So what about division? Well, polynomials are not closed under division. So for example, let's take x to the third and x to the fifth. They're monomials, but remember, monomials are polynomials as well. So we're going to divide the two, and when we do, we get x to the negative 2. And remember, if we have a negative exponent, we do not have a monomial, and therefore we do not have a polynomial. So since we have a negative exponent and they're not allowed in polynomials, then we do not have a polynomial as a result, and therefore polynomials are not closed under division. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.